This is my Physics 2212 Lab 2 magnetic field of a bar magnet. So the purpose of this experiment was to observe and experimentally determine the relationship between magnetic field strength and distance and compare the results using a computational model following the Biot-Savart law. So as a sneak peek into the findings of this experiment, when the magnetometer is far away from the magnet, it measures a near zero magnetic field in the x direction, and as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. And we were able to calculate n experimentally to be negative 2.78 and the magnetic dipole, or mu, to be 3.14. That's using the values of our experiment. The main physics fundamentals used in this lab are the Biot-Savart law, which is shown right here. So this was used in a computational model to calculate the magnetic field. It's basically used to express a magnetic field, with r being the observation vector and mu being the magnetic dipole moment. And then this right here is the distance-dependent formula for the bar magnet, and this is just a linearization of it to be able to put it into a graph. And then this one just is to express the magnetic field's magnitude. The assumptions of this lab were that nothing in the surroundings was interfering with the app with the magnetometer, and that the bar magnet is a dipole, and that the phone remains in the same position for every measurement. The system here is the magnetometer, and the surroundings are the earth and the bar magnet, and the initial conditions were that the magnet was placed on the east and west axis and then calibrated. For the experimental procedure, the first thing we did was determine the location of the magnetic sensor, and then we set up the bar magnet. Then we put the meter stick east and west, correlating with Earth's magnetic field. Then we measured different distances from the magnet corresponding to different magnitudes of its electric field. So this Excel sheet shows the measurements which were used to create this graph. So these are the measurements that we got, and then this is the graph that was created from it. And then from this graph, we're able to calculate n and k, because the slope of the regression line, which is negative 2.78, so that's going to n, and then the y-intercept, negative 14.074, is ln k. So if we take the log, we can find what k is. And then using the distance-dependent formula, which is right here, and the dipole equation, we set them equal to each other, and from there we're able to solve for mu, which is the magnetic dipole, and my calculations are shown right here. So the magnetic dipole, or mu, was calculated to be 3.14. So this is just a snippet of the coding. So the first thing I did was we took this value that we found for mu right here, 3.14, and put that in and edited the magnetic moment line. And then I created this function using the Biot-Savart law to calculate the theoretical magnetic field, to then compare that with the experimental one from the experiment. And then this is another snippet from the coding. So basically here I just created observation locations where the arrows would be placed, and then created the on-axis magnetic field arrows and the perpendicular axis arrows, and changed dperp to match the value from Excel from earlier. And then I created an arrow for the magnetic field at 45 degrees from the axis. So this is the results of the computational model. This is the vector that was given from 45 degrees, and this is the magnitude of that. This is shown by the computational model here. And then the source of error are that there could be issues with the app, there could be interference of another object, there's a couple objects that could mess it up, and then shifting of the phone while taking measurements, because slight changes could mean a difference in the calculations. And then, so here are the conclusion what if questions. So what if the meter stick was laid out at some intermediate angle with respect to the Earth's magnetic field? If this were the case, the results would be much less accurate, because having the magnetic north is what ensured that the x component would be 0. So the magnetometer's results would be inaccurate. And then another what if question is, if two identical magnets were stuck end to end, what would be different? The measurements that were recorded, I think, would double in magnitude.